So we are continuing our review for CBA number 3. We are on problem 10. So a rectangular sandbox will be constructed for the students at an elementary school. The sandbox will be filled to the top of the sandbox with sand. If each bag of sand contains 2.6 cubic feet of sand, how many bags of sand will need to be purchased to completely fill the sandbox? So we are looking for what? This area, exactly, are we are looking for volume. We want to know how much sand will fit in this sandbox. So we need a plan of action. First, we need to find volume. We're going to look on our formula chart for volume. We have a prism. Volume equals big B times H. Now, we know that big B means area of base. Shape is so we can rewrite this length times width times height. So the volume will be 1.5 times 5 times 6.5. That will give us the volume of the sandbox. But is that what we're looking for? Let's keep reading. If the sandbox contains 2.6 cubic, if a bag of sand contains 2.6 cubic feet of sand, how many bags of sand will need to be purchased to completely fill the sandbox? So after we find the volume, we need to figure out how many bags of sand we need to find. So don't forget, we're going to just write us a note. How many bags of sand? To remind us, once we find the volume, that is not what we're looking for. We're actually looking for how many bags of sand we need to know the volume. So let's come down in our workspace, keep our plan of action up here, and we're going to do 1.5 times 5. So 5 times 5 is 25. Write the 5 down, carry the 2. 5 times 1 is 5, plus 2 is 7. We have one number behind a decimal. We're going to move our decimal over one place. So 1.5 times 5 is 7.5. Multiply 5, 25. 5 times 7, 35, plus 2, 37. Now, remember, we don't want to, whichever number we're multiplying by is the number we start our ones place under. So I'm just going to put a 0 there. 6 times 5 is 30. Carry my 3. 6 times 7, 42, plus 3, 45. Add them up. 5 plus 3 is 8. Now we have two numbers behind our decimals in our problem, so we move our decimal 2 places over. So our volume is 48.75 cubic feet. So this is our volume. But remember, we wrote ourselves a note to remind us that we want to know how many bags of sand we need to fill up the sandbag. And they tell us that one bag of sand contains 6.2 cubic feet. So we're going to multiply into 48.75. Now remember, whenever you're dividing with a decimal, you have to move your decimal place over until our divisor is a whole number. So this gets moved over one place, this gets moved over one place. I'm going to go ahead and put it directly above where I want it. So let's start over here. 26 into 48 goes one time. 1 times 26, 1 times 6 is 6, 1 times 2 is 6, is 2, 4 minus, we're going to bring down our 7. Now, how many times does 26 go into 227? I know 26 is pretty close to 25. Think quarters. I always, whenever I'm using dividing or multiplying by 25, I always think quarters. So, 4 quarters go into each dollar. We have 200 here, so we know 8 quarters should go into 22.5. So 8 times 6 is 48. Carry my 4. 8 times 2 is 16, plus 4 is 20. I'm going to borrow from this 2. 17 minus 8 is 9. 1 minus 0 is 1. 2 minus 2 is 0. Now I'm going to bring down. How many times does 26 go into 195? Well, we know 26 times 8 was 208, so it's going to be 7. 7 times 6, 42. Carry my 4. 7 times 2 is 14, plus 4 is 18. 5 minus 2 is 3. 9 minus 8 is 1. I have a remainder. I want to try to get rid of that, so I'm going to row 26 going to 130. I'm thinking quarter, 5. Because 4 times 26 would be 204 plus 20. Okay. So 5 times 6 is 30. Carry my 3. 5 times 2 is 10 plus 3 is 13. So we have 18.75 bags of sand is required to fill up our rectangular prism. Since we go to, when you go to the store, they won't let you buy 18.75 bags of sand. You have to round up. So we need 19 bags of sand. Okay. Okay, so let's move on to number 11. Melody started working at Zhang's Car Wash. She recorded the number of car washes each day during the months of October and November. She displayed the results of the box plot shown below. So here's our box plot. We're going to evaluate the information on it. Which statement best supports the information in the graphs? The data distributed, I can't talk today. Data distribution in October's box plot appears to be skewed to the right. Well, let's think about it. October, it does look like it's skewed to the right, but let's think about what this means. Remember, plot into 1/4 or 25% is here. 25% is here. 25% is here. And then 25% of our data is here. So actually, our data distribution is all skewed, it should be skewed, it's skewed to the left because the majority of it is over here. So I know that's confusing, but A is not the correct answer because our data distribution is actually skewed to the left, even though at first glance it looks like it's skewed to the right. 2, the interquartile range of the two boxes is the same. Well, that's comparing our two boxes, and that is 2. 24 minus 24 minus 22 is 2, and then 19, and that is 2. So October and November's interquartile range is both 2. So that appears to be the correct answer, but let's keep going. The median number of car washes in October is less than the median number of car washes in November. Remember, median is the line in the middle of our box, or our quartiles. So November was 18, October was 23, October is greater than November. So, oops. It distributes box symmetrical. Symmetrical means it's even on all sides. We have this big area here, and this on our whiskers. So that is not symmetrical, meaning if you folded it on the median, they would be mirror image of themselves. So it's not D. So it is in fact B. The interquartile range of the two box plots is the same.